Hello everybody, this is Dr. A, and in this video we are going to be going over the basics of right triangle trigonometry. So in order to best maximize your learning of this material, you want to write down everything I'm saying and move along with me, and of course pause the video as needed. So to get started, let's go ahead and draw a right triangle. So the first thing I'm going to draw is the hypotenuse, and then I'm going to slowly draw the horizontal leg and then the vertical leg of this right triangle. So here we go. Now we're going to call the length of this horizontal part of the right triangle x. So this is what we call a dimension line right here, and we're saying that this bottom leg right here has a length of x, some value, let's call it x. And then in a similar way, we're going to draw the vertical component of this right triangle as dimension y. So it has some kind of length of y. And then the hypotenuse, which is this diagonal dimension, let's just call it r, okay? So before we do anything else, let's look at why this is a right triangle. Well, we call this a right triangle because one of the interior angles has a 90-degree angle or a right angle. Now, what about the other two angles? What about these guys right here? Well, let's call them some generic name. Let's just give them a name. Let's call this angle down here Greek letter theta, and let's call the angle that's up here from the vertical axis, let's call it Greek letter phi. So if you recall your Greek alphabet, this is called theta, Theta, and then this letter in the Greek alphabet is called phi. And we just use these very commonly for angle designations, okay? Now, let's look at how all of these are related. All of these values are related together. Well, first, when you have a right triangle, you can use the Pythagorean theorem. And so by the theorem of Pythagoras, our old friend, we can say that the hypotenuse r is equal to the square root of x squared plus y squared. Okay, so again, that comes from a squared plus b squared equals c squared. That's maybe how we first learned it, but we're going to be a little more sophisticated and say r equals square root of x squared plus y squared. Okay, the next thing we need to keep in mind with the right triangle is how all of these sides are related to the interior angles, theta and phi. Okay, so the first term we're going to define is what's called the sine. Now the sine, the sine of an angle, whenever you have a right triangle, is defined very specifically as the following. So let's write this down. We're going to say sine of angle theta is defined as the opposite side divided by the hypotenuse. Okay, so what do we mean by that? Well, whenever we have an angle theta here that's part of a right triangle, the side that is opposite of where this angle is located is what we call the opposite side. Now that's going to be this vertical side here that has a length of y. And then of course the hypotenuse is this diagonal length right here that we're calling r. So we can say the sine of angle theta, of this angle theta, the sine of this angle is going to be equal to y over r. Okay, so that's our first definition. Our second definition is going to be what's called the cosine. So the cosine of an interior angle within a right triangle is defined as the adjacent side divided by the hypotenuse. Okay, now what does the word adjacent mean? Well, adjacent really means next to, okay? So when we have angle theta here, the side that is adjacent to angle theta that is not the hypotenuse is going to be this side with length x. So x right here is our adjacent side to angle theta. And then, of course, the hypotenuse is still r. So this is going to be defined as the length x divided by r, okay? Now, let's look at our third definition in right triangle trigonometry, and that's going to be what's called tangent. So we abbreviate tangent as TAN, and we have the tangent of angle theta. And it turns out that the tangent of an angle within a right triangle is equal to the opposite side divided by the adjacent side. So we can write this as opposite side divided by adjacent side. So if we just look at our right triangle figure that we have here, theta has an opposite side of y because the side y is on the opposite side of the triangle compared to where theta is. And then adjacent is the side that is next to angle theta that is not the hypotenuse, because the hypotenuse is a separate third side of this triangle. So maybe pause the video and you tell yourself, you tell me, even though I can't hear you, you tell yourself and you tell me what is opposite over adjacent. Well, that is going to be equal to y over x. So that's the definition of tangent of theta. Now, these trigonometric operations, sine, cosine, and tangent, are of an angle. So you can't really have sine all by itself. You take the sine of an angle. You take the cosine of an angle. You take the tangent of an angle. So let's look at what would be the sine, cosine, and tangent of this other angle that we have here, phi. Phi and theta are complementary angles with one another, okay? So what is going to be the sine, cosine, tangent of angle phi here? Well, we're going to go through this a little bit faster now. So let's look at what is the sine of angle phi. Well, you still have the same definition as we saw before. The sine of any angle is its opposite side divided by the hypotenuse in that triangle. So again, we still have opposite side divided by the hypotenuse side. I'm just going to abbreviate these for us to write a little bit less. So what is the side that is opposite of angle phi? Well, based on angle phi, the opposite side is x. Okay, it's this length x right here. And then, of course, the hypotenuse is still the same hypotenuse. It's r. So when you are referencing this angle phi in this right triangle, we're going to say that this is equal to x over r. What about cosine of phi? We're going to write cosine of angle phi. It's still adjacent side over hypotenuse. But again, we're looking at a different angle now. We're looking at phi, not theta. So what is the adjacent side to phi? Well, when you're looking at phi, the adjacent side is this length right here, y. And so we're going to write y over r. And what about the tangent? Tangent of phi is still opposite side over adjacent side. So again, looking at angle phi, the opposite side is x and the adjacent side is y. So when you want to get the tangent of phi, you are going to write x over y. So the important thing to take away from this particular video is that when you are looking to find the sine, cosine, or tangent of an angle, you need to be very careful as to where that angle is. And you can always go back to these basic definitions of opposite side, adjacent side, and hypotenuse. And then depending on where your angle is, you can craft the more specific fractions like y over r, x over r, and y over x, Or, depending on what angle you're looking at, maybe you have x over r, y over r, or x over y. So again, look very carefully at what angle you are observing, and then use the basic definitions of sine, cosine, and tangent to craft those specific fractions. And that's going to be the end of this video.